Roughly 13 years ago, I shot a video of my little Stirling motor here that, much to my surprise, has had nearly 1 million views now, which for somebody like me is a pretty cool deal. Yeah, at the time, I was kind of shooting off the cuff. Several of the things I said about the deal were wrong. So another thing 13 years ago is I'm pretty sure I shot it on this exact same desk. And 13 years ago, Pole Position was running in the background. And he's still around. He's right back here. Let's see if I can find him here. Yeah, there's Pole Position. A lot of people would hear that and say, hey, Pole Position. Anyway, so what I'm going to do first off is just light this guy up. And I'd mentioned a couple things that I'd done wrong. One of the main things is that I'd identified this as the power piston. That is not correct. The power actually comes out of here. This is the heat reclamation, and this is called a heat pump, or not a heat pump, but this is where the heat is collected. And anyway, doesn't really matter. This is where the power side is. I can throw up a diagram that shows how Stirling motors work. Honestly, if you're really interested in it, you can just Google that. But what I can show you though is something that's interesting about this machine is that it's often called a hot air machine. And it's not really hot air. It's really a heat difference engine. The difference in heat between here and here is what makes this thing go. And so the hotter this is compared to that, or the cooler this is compared to that, the more efficient, or actually not more efficient, the faster this engine will run. It's extremely efficient anyway. Phillips Engineering back in the 70s proved that you could run a variety of different kind of gases inside here, and they even made some with fluids in it. And those fluids are, well, one of the things they proved with all that is not only that you could run on fluid, but that you could make one that was lethally explosive, which apparently they managed to do on at least one occasion. But anyway, let's fire this guy up here. This is kind of hearkening back to the way it ran 13 some odd years ago. See if he still fires up. So what I'm doing right now is I'm putting heat into this side, this part of the cylinder right here. And when this gets to a certain temperature, and I'm not even really sure what that temperature is, this particular motor needs a pretty big difference between the two sides. Let's see. It's reading the flame. It's not really reading the cylinder. I've got about 180 degrees right now on the cylinder. And 79, 80 degrees on this side. Yeah, 83 on that side, and about 211 right now on the other one. Can you see that? Yeah. So let's see if this guy will fire up. Yeah, sure enough. All right. So this needs about 100, 150 degree difference. I got to hold it down or it'll start rolling around. So what I'm going to do now is I'm going to blow this out. Pause this for a moment. We're going to see what happens if we can actually radically increase the temperature difference between these two sides. More specifically, I'm not going to make that side hotter. I'm going to make this side colder. And let me pause for a minute. I'll be right back. Okay, something I forgot to do before was to check the RPM of this motor. Obviously, if we're going to try to do something to make it go faster, we need to know how fast it's going to start with. Incidentally, if this kind of thing interests you, this might be a good time to do the whole subscription thing and clicking on the alarm thing and stuff like that, because I have a couple more motors that I'm really wanting to play with. Most notably, I've got this little guy that is so efficient that it can run on nothing but cold, being a heat difference motor. I've got this 16-cylinder bad boy that is really cool to watch run, I'm telling you. He is a neat guy. If I might fart around and show you the Stirling motor that I 3D printed. And then I've got this crazy thing, which you may have seen before, you may not have. kind of marketed as a kid's toy, but this is actually a heat difference engine that runs on liquid, much kind of like I talked about before. And the design behind this is really kind of fascinating. But if you want to see that stuff, that'll be in later videos. Check back. So let's fire this guy up again real quick, get a reading and see how fast he's actually running. Get some heat in it here real quick. I put a little piece of tape on there and a piece of reflective tape. Theoretically, every time that thing goes around, it'll trigger my little RPM gauge over here. We can get a decent reading on it, and we can try to speed it up some. Make it even more efficient by making even more of a temperature difference between the two sides. Doodly-dee-dee. There we go. Yeah, he's running pretty good. Let's see, I think we've got a average of about 1,064 RPM. Not too bad for running on about a candle power. Okay, let's let him slow down some. So the first thing I'm going to do is put a little more fuel on it. These little fuel tablets run out pretty quick. I don't have hardly any left. Okay, we'll put that guy on there. Come on, get on there. You're trying to burn me. Okay. And then, again, heat difference, right? So what I'm going to do is let's throw some ice over here on these cooling fins. If I can get it kind of on it, it'll sort of hold on its own. Let's get some heat back on that side. Again, heat difference is what the deal is here, so. My little pieces of ice are melting pretty quick. Ooh. Son of a gun. Yeah, I can tell it's moving quicker. I don't know if you can hear it, but it is certainly moving faster. The ice is falling off. 2,514. Not too bad. Let's let this little guy run for a little while. Water's going to put the flame out. So there you go, heat difference motor. I'll show you those other motors later. They're pretty cool. You got any kind of comments or anything? Please, please, please mention them down there. I'll answer any questions that I can answer. And also, if you go back and look at the other video that started all this, it does explain a little bit more about how this engine works, albeit with a couple things that are wrong. But and it's at like 987,000 views right now. If you guys could help me push that over 1 million views, just from a personal ego standpoint, that would be fantastic. And I will see you next time, and thanks for watching this.